Let's look at example 4 of the StatX review. So determine the reactions at A and B along with internal forces at point C. This is a pin. You can see it's preventing lateral translation, and this support itself is preventing vertical. This one's only supporting the vertical, so if I were to idealize it, I would see this. Got a 900 Newton force at the end on this device, and I have the distributed load acting over that 2 meter span right there. I've got AY, BY, AX. Simplest one is sum our forces in X, and we find AX is 0. If I sum my forces in Y, I'm going to have two unknowns, so I'm going to sum my moment about one of them. I'm just going to choose A. I have 600 newtons per meter acting over 2 meters at a moment arm of 2 meters. If you wanted to make that, so this would be 600 times 2 meters, and then my moment arm is the distance to A to that concentrated version of the distributed load. 600 times 2 times 2 plus BY times 4.5 meters, right, the distance from A to B. And then we have, this one is negative, BY is positive, our 900 is negative, and it is 6 meters away. So that gives me a BY of 1,733 newtons. And then I can sum my forces in Y. I have minus 600 newtons per meter acting over 2 meters for minus 1,200 newtons, minus 900 newtons, plus AY plus BY equals 0. And that is going to give me AY equal to 367 newtons, both of them upward. So we've gotten AX, BY, AY, and then we just need internal forces at point C, so we are going to cut. Again, I could draw everything to the left, or I could draw everything to the right, up to you. I am going to draw the yellow. I'm going to draw this. I'm going to see part of the 600. I'm going to see the 367 that I found. And when I cut, I release shear at C, axial at C, and moment at C. Sum my forces in the X direction. There is no axial force. Sum my forces in the Y. Got minus 600 times 1 meter plus 367 minus VC equals 0. So VC is equal to minus 233 newtons, so it's actually upward. Take my moment about the cut, so moment about here, and I've got 367 going clockwise 2 meters away minus my 600 newton per meter acting over 1 meter, half a meter away. And then I have the MC I'm trying to find, and that all should add up to 0. So I get MC is equal to 434 kilonewton per meter. This should be a positive, because this one is clockwise, that one is counter, so negative and positive. And gets me to that 434. And I got a positive number, so it is correctly drawn. Again, if you wanted to draw it, it would look like this. Do a bit of a sanity check. 367, 600 newtons per meter, and this should be 233 newtons, and this should be 434. That is Newton meters. There is our body in equilibrium.